Director, IIMT College of Science and Technology, Dr. Poonam Pandey ma'am, Dean, Director, Dr. C.S. Yadav sir, my dear colleagues, and all the coordinators and representatives of IIC, all the attendees present on virtual platform. I, Aisha Sherwani, with Mr. Kamlesh Ahirwar, Assistant Professor, IIMT, College of Science and Technology. Welcome you all on today's workshop on the topic critical thinking and utilizing renewable energy technology to mitigate climate change. I feel honored to have Dr. Subhuhi Sherwani as a resource person. Dr. Subhuhi Sherwani is a lecturer at University of Ottawa, Canada. Prior to this, she worked as instructor, postdoctoral research fellow at the Memorial University, Canada, followed by postdoctoral fellow at the University of Ottawa, Canada. She did PhD from Department of Material Science and Engineering from IIT Kanpur, India. She did her master's in nanotechnology from AMU Aligarh. She has over 10 years of experience in mitigation of climate change. She works on renewable energy technology for space heating and cooling. Over to you, Dr. Subhuhi, ma'am.
Thank you very much, Aisha, for introducing me over here. Now I'd like to present my work on climate change. Yeah. So I hope you are seeing my screen now.
Yes, ma'am. You're visible.
Yeah. Yeah, so I'll be talking on critical thinking and utilizing renewable energy to mitigate climate change. So we know that since the climate change, it is really an important issue nowadays. And what is climate change exactly? It is a change in weather condition of a particular place over a long period of time. And what is the effect of the climate change? As the rising sea levels, severe storms, drought, icing melt in the Arctic and Antarctica, and loss of species, food crisis, and so on. So it's all related to the climate change, but we need to understand the climate and weather. So these are two different things. So weather is a weather of a particular region over a short period of a time. However, climate is a weather of a particular region, such as North America, Asia, for a over a long period of time. So if you are talking about day-to-day temperatures, such as like over here in Canada, so today it's snowing. So the weather is 1 degree centigrade and it's snowing. And if you talk about climate, so climate over here, it's a cold climate in North America. So climate and weather, these two things are very, very different. So climate change, we know that because of the climate change, there are severe extreme weather events happens, such as extreme cold in winters and extremely hot temperature during the summers. And why it is happening? Because the emission of the greenhouse gases. We know that our Earth, Earth, it's a planet, and we know that it has a different atmosphere other than different planets. So because the presence of a thin layer of a greenhouse gases, and these greenhouse gases are CO2, carbon dioxide, nitrous oxide, methane, water vapor, and ozone. But the thing is that here are some few fluorinated gases as well. But we will be talking on this particular gases in our next slide. But the thing is that the contribution of these gases causes the climate change. And we know that since carbon dioxide has a major portion in the greenhouse gases, that is the 60% of the contribution of the carbon dioxide in greenhouse gases. That's why it's up. The climate change is causing mainly because of the carbon dioxide. And carbon dioxide is coming from the fossil fuels, and fossil fuels such as coal and petroleum, natural gas. And so why these fossil fuels and how these fossil fuels are producing? Because these fossils are the microorganisms. And these microorganisms are trapped inside the rocks at high temperature and pressure. So when for several years, if they trap inside the rocks, they turn into liquid, and those liquid can be extracted and used to run the cars or for the electricity. So there are so many ways where we can utilize these fossil fuels. But the thing is that these fossil fuels are depleting. So they are depleting, and these are the non-renewable energy sources. So that's why we are focusing to adopt new renewable energy sources. We know that renewable energy sources such as sun and wind, these sources are from the ancient time. But the thing is that the technological development. So technological development is a key. So how to utilize or how to critically think about those particular technology, we will be discussing in our next slide. And from this climate change, there are so many effects taking place, such as acid rains. How acid rain taking place? So this tree takes nitrogen and phosphorus through the soil, and this nitrogen and phosphorus goes from roots to top into the tree. But the thing is that when this tree is dead and burned, so these gases, these elements turn into the gases, and these gases captures water and turn into the acids such as nitric acid and sulfuric acid. So these acid, because of these acid, we get, sometimes when it rains, we get burning on our skin. So this is because of the climate change, and it also deteriorates our plants and soil and crops. So we know that there is a need of renewable energy, because from many years we are dealing with the fossil fuels, but due to decrease in the fossil fuel supply and increase in the demand of the new and clean energy sources, we are focusing to adopt renewable energy sources. So renewable energy sources are clean. Renewable energy sources are clean and abundant. So it is cheap as well, because we usually we buy petroleum and natural gas, so it costs. But the thing is that the wind and solar energy, it's all free, so it's quite a cheap technology. But the thing is that to utilize that, we need a different kind of technological development. For that, we require a quite critical thinking. So before going into the renewable energy technology, I would like to discuss the global warming here. So here are some fluorinated gases which causes a 3% of the into the greenhouse gas emission, particularly in 2017. So here we are seeing that major contribution is through the carbon dioxide, which is 82%, and methane, it's 10%. Nitrous oxide is contributing 6%. However, fluorinated gases 3%. So we know that, what is the source of these fluorinated gases? So the source of these fluorinated gases are refrigerants. So refrigerants like in cars or in air conditioning. So these are because of the these fluorinated gases. To avoid that fluorinated gases, we require to remove these fluorinated gases with alternative fuels. So these fuels maybe these fuels may be ammonia. And so we can remove, and some other fuels, but not fluorinated gases, because they are also, since the contribution is low, but they are also contributing into the global warming. So here we are seeing the greenhouse gas emission in Canada from 1990 to 2017. And we are seeing that the trend is almost, so it was low, like on the y-axis, it is in megatons of carbon dioxide equivalent. So the trend was low, but as year passes, the trend goes up, and then it gets stabilized. Then again, it has a slight dip, and then again saturated. So during the 2017, it has a saturation, but the thing is that still there is 1,000 megatons of carbon dioxide production and emission. Now we are seeing the global rise in temperature and carbon dioxide. So yellow line is the carbon dioxide emission from 1880 to 2017, and red curve, zigzag curve, is the temperature rise over the years. So we know that from 1880 to 2017, the carbon dioxide emission is like going up. So the right hand side y-axis is in parts per million, and left hand side of the y-axis is in the degree centigrade. So now we are seeing that up until 2017, the temperature rises 1.1 degree centigrade. However, the carbon dioxide percentage is like 410 ppm. So yeah, it gradually going up and up. So both the temperature of the earth, as well as the carbon dioxide emission, both are going up. So now here we are seeing that over the years, what is the heat trapping gas levels of the nitrous oxide, methane, and carbon dioxide. So carbon dioxide is in the parts per million, nitrous oxide in parts per billion. However, in methane is parts per billion. So if you are seeing the blue curve, it is for methane, and black curve, it is for nitrous oxide, and red curve is for the carbon dioxide. And we are seeing that over the years, until 1500, it is all constant, means it is just it has a few humps, but as the 2000 year, so the concentration is like going up gradually. So yeah, these nitrous oxide, methane, and carbon dioxide, these greenhouse gases are rising so quickly during these years until 2000. And then this trend, that's only the carbon dioxide trend from 1960 to 2010, we are seeing here that that carbon dioxide gradually increasing. So it seems it's really an alarming position. So here we have some important points to note down, that the first conference, that is the UN Conference of the Environment and Development, is held in Rio de Janeiro. So what was the result of this particular conference? It resulted in a framework of Convention on Climate Change. So it's UNFCCC among like between the countries. So they gather together and they form a framework to mitigate the climate change. To fight against the climate change. But the main event is the Paris Agreement, which was signed in 2016, and it has one major goal, that we can limit the global temperature below 2 degrees centigrade. So, and that too the level should be, we should limit the temperature until 1.5 degrees centigrade. So that was the major goal for the Paris Agreement. Yeah, so I would like to just focus on the key point over here. That's a sense that they have made a strategy that was the 2020 targets. So means the carbon dioxide reduction should be 20% and increase of the renewable energy market by 20% and increase in the energy efficiency by 20%. So it was 2020 targets. And so they formed that, and so still now many COP conferences are going on. So and their main target is to limit the global rise of temperature and below 2 degrees centigrade. And to mitigate the climate change, we should utilize more and more renewable energy technologies. So we should, since we are talking about the renewable energy, we should know that what is energy. We know that energy is conserved quantity and it cannot be destroyed. We know it's just a definition we already have studied it in our high schools. So it's like energy is a conserved quantity. It cannot be destroyed, but can change into one form to another. And its SI unit is joule, and it has the different forms such as electrical, nuclear energy, kinetic energy, and the different forms of the energy. The main emphasis on the potential energy and kinetic energy. So potential energy is possessed by a body due to their relative position with respect to the other object. However, kinetic energy is the energy of an object so due to its motion. So we have renewable energy, we have non-renewable energy, and we have secondary source. So what is secondary source here? So we know that renewable energy that can be recharged, that can be replenished, but non-renewable energy sources that cannot be replenished, that cannot be recharged. However, the secondary energy sources, so we need to just focus on this, because the secondary energy sources are the sources that can be derived from the primary energy sources. And the primary energy sources are the renewable energy and non-renewable energy. So, so the example for the secondary energy sources are hydrogen and electricity. So we can derive electricity and hydrogen from solar energy, wind energy, geothermal energy, biomass. So we can generate electricity from these primary energy sources. So types of renewable energy are, first of all, solar energy. So we all know that solar energy, it is abundant. And but the key point over here is that solar energy is also classified into two parts, like concentrated solar systems and photovoltaic solar systems. So here the concentrated solar systems are based on the thermal energy technology, where the solar radiation converts into the thermal energy, and then from thermal energy it can convert to the electricity. So it in the thermal energy systems, there is no direct electricity conversion. So first the solar energy will convert into the thermal energy, and then thermal energy to the electricity. So on the other hand, for the photovoltaic system, so it's a direct conversion of solar energy into electricity. So yeah, so so based on this technology, we have lots of solar power plants, like concentrated solar power plants and photovoltaic power plants. So we can utilize solar energy through that. And then we have wind energy. So we have the wind turbines, which are of different geometry, horizontal and vertical type. So we are using the wind energy to generate electricity. So, and then we have geothermal energy. From geothermal energy, like how we are utilizing the geothermal energy, we are extracting the energy deep inside the earth, where the temperature is around 4,000 degrees centigrade, and we are extracting that energy for the space heating as well as to generate the electricity. So that much energy is huge. And then we have biomass. So biomass, how we are producing energy through the biomass, it's a really a different game, because we have different category of biomass. I would like to tell you over here, the main thing is like garbage, whatever garbage we generate a day-to-day basis. So if we are utilizing that particular garbage in producing the energy, such as either the gas or fuel, so it's like a bioenergy. So how we are utilizing it? Through the anaerobic digestion. So anaerobic digestion is the process where we ferment that particular garbage or waste material into the fruitful energy, energy fuel or energy gases. But the thing is that over here, during the anaerobic digestion, we produce solid material as well as gaseous material. So gaseous material can be used in vehicles as a fuel, but the solid material is what is produced over here that can be utilized as a fertilizer. And then here we will be talking on non-renewable energy sources. So non-renewable energy sources, we all know that these are the fossil fuels such as coal, natural gas, and here we are also saying the nuclear energy. So nuclear energy is non-renewable energy source, but not the fossil fuel. So we know that all fossil fuels are renewable energy, but not all non-renewable energy sources are fossil fuel. Why? Because nuclear energy is non-renewable energy source, but it is not a fossil fuel. So because nuclear energy is produced through the uranium, and uranium is usually mined. Then yeah, I think I have almost completed this, the renewable energy part, but I would like to focus mainly on the, to store this energy. So we know like how to produce these, how to extract or how to make technology based on the renewable energy sources. But the thing is that to store that energy is also a major issue, and how to store that particular energy, like electricity or solar energy, like thermal energy from solar energy, how we can store that thing, like in batteries or in materials. So battery can be of any type, or so here many like innovative ways to store renewable energy into the batteries. So we can also use lithium-ion batteries. But here the thing is that which is a commercialized battery from Honda. So it's a mobile power pack, and it can be used for wind power storage, solar power storage, water power, like the hydropower storage, and biomass. So we can store this kind of energy into this particular battery. So storage is also a major issue, because we know that there are peak hours when sun is there, but during winter, during night, sun is not there. So we need to store energy. So for those periods when sun is not there and during off-peak hours, so for that, storage is required, and that storage can be done by these kind of batteries. So it is important to have such storage devices with with the energy sources such as suppose we have a big solar power plant and we are continuously generating electricity. So it also has some like a power hub, and through that there is a transmission line going, and those transmission line going to the residential area, transportation, and then industries. But the thing is that it is the a continuous production and continuous transmission. But during winter, during nighttime, how you are utilizing that particular technology, since if sun is not there, then how you are going to utilize that particular technology? So to utilize that particular technology, you need to have for every, like from 24/7, then you should have a particular storage system or alternative sources, such as so there is a trend in concentrated solar power plants. So usually, so for the nighttime and for the winter time, it can also be clubbed with the oxy-fuel burners. So oxy-fuel burners are the like it can be operated through the oxygen. So that can generate, since the traditional burners use use air, which has all the gases involved. So it's a like major contribution to the greenhouse gas. If we are using only oxygen, so yeah, so there is a less greenhouse gas emission. So we know that the consumption of energy also tell us the growth of a particular region. So yeah, so consumption of the energy could be an industrial area, transportation area, domestic area, agriculture, and so on. Here we are saying the world energy scenario, like global power capacity by source, and the stated policy of IEA, which is International Energy Agency. So it is a World Outlook 2019, the particular issue. So here we are seeing the energy scenario from 2000 until 2040. So it's a prediction. And here we are seeing that for the nuclear energy, the curve is almost flat. So from 2000 up until 2040. However, in the wind and hydro, it is slightly up, like y-axis is in the gigawatt. So it is approximately, we could say 1900 gigawatt. And coal, yes, since coal is a non-renewable energy source, still it has a, yeah, it is not limited until now. So it is also going until 2040. And now the production of the like power is by the coal is, yeah, more than 2000 gigawatt. And if you could see the trend of the solar photovoltaic, so it is huge. It is going beyond 3000 gigawatt, means the solar photovoltaic will be the major power source during that particular 2040. So now we are going to see the electricity generation, the life cycle greenhouse gas emissions by the electricity generating technology. So these technologies are utilizing, so there are all technologies involved, means renewable and non-renewable energy technologies. So the left side is the electricity generation technologies powered by renewable sources. However, the second right-hand side part is the electricity generation technologies powered by non-renewable energy sources. If you could see that there are biopower, which is also clubbed with the carbon capture and sequestration. So here a new technology involved, which is carbon capture and sequestration. So what is that technology? Means we are capturing carbon, and capturing carbon and storing deep inside the earth. So, and why? For the geological formation. So what we are just completing removing carbon dioxide from atmosphere, and yeah, it is just completely vanishing into the earth. So that's what we are doing over here. So for the biopower, if you could see in here the yellow curve, if the technology is clubbed with carbon capture and sequestration, the life cycle greenhouse gas emission is in negative, means there is now no pollution involved for this particular technology. However, if a little bit, if for the biopower, the maximum life cycle carbon capture without life cycle gas greenhouse gas emission without carbon capture, there is slight greenhouse gas emission up until 350 carbon dioxide per kilowatt hour. So, and if you could see, yeah, so photovoltaic trend is a little bit low, and the ocean energy, it has a very, very low contribution in the life cycle gas emission because ocean energy, it requires very less complicated equipments, and the equipments that is involved, it has a very low amount of the carbon dioxide emission, and it is mainly coming from the water, like hydro, like ocean or lakes, or whatever the water resources available. So we're extracting the energy from that. And then, yeah, wind energy also has some contribution, but if you could see the non-renewable energy sources, so yeah, contribution is huge, approximately 1700 carbon dioxide equivalent to kilowatt hour. But if it is clubbing with the carbon dioxide, carbon capture and sequestration, then the emission is going very low. Yeah, now we are seeing the estimated levelized cost of electricity for new generation entering and service up until 2019. So here, different technologies. So a point to be noted over here is like we have the non-renewable and renewable both technologies involved here, and the cost is in the US dollar per megawatt hour. So for the conventional coal, the cost is below 100 US dollar per megawatt hour. And for the advanced coal, yes, it is slightly up. But if you could see for solar thermal, yeah, levelized cost of electricity for new generation entering service is like, it's huge. It's around 240 US dollar per megawatt hour, and all other technologies are lying below 100. So that's okay. But the solar thermal is like, it's a huge cost. And if you could see the wind offshore, it is coming on the second number. Yeah, and third one is advanced coal with carbon capture and sequestration. Now we are seeing the average renewable power generation cost in the fossil fuel range, and that is in particularly 2017. So we are seeing that there are biomass, geothermal, hydro, solar photovoltaic, concentrated solar power, offshore wind, and onshore wind. So if you could see the onshore wind, hydro, geothermal, and biomass, it has a lower cost than the fossil fuel cost range. However, the photovoltaics, solar photovoltaic and concentrated solar power has high cost. That is not in a range of the fossil fuels, like more than that. So that is around. If you could see the solar photovoltaics is approximately 0.29 US dollar per kilowatt hour. So best thing to utilize over here is like geothermal, hydro, and biomass is also good. here we are seeing the electricity, like it's just it's a prediction until 2050. The electricity becomes the main energy source by 2050, and how the consumption, like between 2016 and 2050, it's a comparison between these 2 years. So let's see for the 2016, what's the energy scenario. So here the total energy consumption is 395 exajoule. So 14% of contribution is through the coal, 16% contribution through the natural gas, and 36% through the oil. However, in electricity, so 19% is from the electricity, but point to be noted over here that renewable energy share in the in the electricity is 24%. Means in 2016, the electricity mainly, so only 24% of the electricity is generated by the renewable energy sources. In here, if you could see the comparison for the 2050 year, then here the total energy consumption is 351 exajoule, so which is less than 2016. And here we are seeing that the electricity contribution is 49%, and here the major contribution is through the renewable energy sources, which is 86%. Means the 86% of the energy is from the renewable energy sources. And yeah, and similar trend is like district heating. So 77% of the contribution is from the renewable energy sources. And we are not seeing the oil and natural gas, because these are fossil fuels. They still have some contribution in here, since not like 2016. In 2016, it has a very high contribution, but 2050, it has a low contribution. Now it's a forecast up to 2025 from, so the solid line over here, it's all real data until 2017, and the dashed lines, these are the predicted data. So it is saying that for the solar photovoltaic, it will be a major source until for 2025. And that's why, so we should note it, we should note down the units for the wind, photovoltaic, and concentrated solar thermal. So it's in the gigawatt, and battery is in the gigawatt hour. So here we are seeing that the battery, which is in the gigawatt hour, yeah, it is showing approximately 3,750 gigawatt hour contribution until 2025. But the main contribution, if we are talking about just, we are not focusing on the storage device. Now we are just focusing on the energy sources. So if we focus on the particularly energy sources, then solar photovoltaic, it has a major contribution up until 2025. It is approximately 3,250 gigawatt. Then we are seeing the global energy employment by technology from 2012 to 2018. And okay, Aisha, is there any time limit?
No, ma'am, please continue. Approx 1 hour, 40-50 minutes. So.
Okay, that's okay. Thank you. So if you could see in here the global renewable energy employment by technology from 2012 to 2018, then you could see over here there are solar photovoltaic, which is in the yellow color, bioenergy, which is in the green color, and then there is a wind energy, solar heating and cooling. So solar heating and cooling utilizes the concentrated solar thermal technology over here. So since this curve is also divided into two parts, first is like upper part is mainly based on the hydropower, So here if you could see the major in the 2012, the contribution is 1.66 for hydropower, but for the 2013, the contribution rises to 2.21 for the hydropower, particularly for the hydropower. So means that much employment has generated. And it became stabilized until 2018. If you could see that employment, renewable energy employment by 2018, it is increasing. So trend is almost increasing. If you could see for the bioenergy, for the 2014 and 2015, it was high, but in comparison to the solar photovoltaic, so it is it's not that much high. So for the solar photovoltaics, the trend is increasing, and it is increasing up until now. So here we are seeing the renewable energy employment by the technology. And if you could see I would like to let you know that the jobs are in thousands in here. If you could see the x-axis, the jobs are in thousands. So if you could see the tide and wave ocean energy, here the approximation is like 1,000 jobs for the particular 2017. And if you could see CSP, the job is 34,000. And then there is a municipal and industrial waste, which is like, we should say that biomass, it's a category of biomass energy. And so that is approximately 41. And so maximum employment is from the solar photovoltaic. 3,605,000 jobs available for this particular technology, solar photovoltaic. So major employment is through the solar photovoltaic, and then there is liquid biofuels and hydropower. But so solar photovoltaics is as always on a first number in everywhere. So if you could see the employment with the 10 best countries, so here the China, it is contributing 61% of the photovoltaic jobs. And so the jobs are in million. And and the x-axis are showing the different countries: China, Japan, United States, Bangladesh, India, Malaysia, Turkey, Germany, Vietnam, and Chinese Taipei. So here the total contribution of these 10 countries is like 84% of jobs are for the PV photovoltaic. So, and here if you could see for the biofuel, so these 10 countries are contributing 90% of jobs in that particular biofuel, and Brazil is contributing 40% alone in the biofuel jobs. So so there is also United States is also contributing. It's on second number, then Indonesia, Colombia, Thailand, China, India, Romania, Poland, and Malaysia. So so it is also contributing in the biofuel. So now here we are also focusing on the net trade of the in solar energy and wind energy, and particularly we are in the solar energy, we are seeing the solar photovoltaic technology. So if you could see in here so United States has 0.02% of the share, and then China has the 8%, Spain has the 15%, and 29% from Germany, and 42% from the Denmark, and 6% the rest of the world. So this is just talking about how the export and import is happening like throughout the scenario of the in the particular wind energy technology. And if you could see the solar photovoltaic, so 52% rest of the world. However, 4% from the United States, 5% from Germany, and 7% from Japan, and 31% from China. If you could see in here the bar graph, the net trade, Denmark is like high, so it's it is reaching up until 2,700 million euros. So it seems so net trade, but yeah, Turkey, some values are in negative, so means mainly they are importing. So and if you could see China in here for the solar photovoltaic, so yeah, it has a net trade in million euros. Above 6,000 million euros. But yeah, if you could see for the other countries, the trend is in negative, means mostly import is happening in their particular countries. Yeah, so now we are seeing in here the trend in the cost in photovoltaic cells, since we are seeing that solar photovoltaic technology is well developed. It is giving so many employment. It is producing lots of energy, and main contribution is through the solar photovoltaics, and it is a well developed technology. So now we are seeing the trend of the solar photovoltaic cells. So what's the cost per watt for this particular photovoltaic cell? So if you could see in 1977, the cost was $76, and by the years it drops gradually. So in 2015, the cost is 30 cents.
So ma'am, we
So it
time, so can conclude.
Sorry, Aisha, I couldn't hear you. Can you please repeat it?
Unless time is left.
Less time. Yeah, I'm just finishing up soon.
Yes.
Yeah, so it is happening because of the since when the technology was just developed, there is less companies, less consumers, and there is the efficiency of this particular product is less. But as the technology is developed, more companies, more users, and the efficiency is also much high. So now by 2016, the efficiency has reached from 2% to 34%. So efficiency is very high. So that's why that also contributes in the decrease in the price. So with that, I'm just wrapping up my talk, and feel free to ask questions if you have any.
Thank you so much, Subhuhi ma'am. It was an enriching and learning session. Now I would like to invite Kamlesh sir for vote of thanks.
Thank you, ma'am. Thank you so much. Thank you, Asha, ma'am. First of all, I very thankful to our honorable guest, Dr. Subhuhi Sherwani, ma'am. And Dr. Subhuhi explained very easy and knowledgeable for each and every that how to save Earth or how to save planet. Also focused on fuels, sustainable development in the digital era. The development sustain that save our life, how to save our life, how to save our environment, even how to save planet. This is very good information, ma'am, us and our students and our listeners. And also aware from global warming, renewable energy, like from coal to electricity, and also discuss the conventions, what is doing the UNFCCC or Kyoto Protocol, also Paris, even. Very nice, ma'am, very information. And how to save environment, that's very nice, ma'am. Thanks, ma'am. Thank you so much. And also thanks to our honorable director ma'am to giving this opportunity. And also thanks to our Dean sir, and also thanks our HOD ma'am and our IIC convener ma'am and my colleagues. Thank you so much, Aisha ma'am. And again, thank you, Suburi ma'am. Thank you so much.
Yeah, thank you very much, and thanks for calling me over here. And it was a good opportunity to present the work what I'm doing right now in here. And yeah, I wish you good luck in your
Thank you.
future endeavor.
Once
Thank you,
again,
sir.
I'd like to thank Dr. Subuhi ma'am for giving her valuable time. With this note, I, Aisha Shirwani, sign off.
Thanks, sir.
Bye.
Thank you.